Alright, so for the code portion, I really only want to show three or four things, and that will be getting the cards to display correctly, interpreting the controls, and undoing moves. So, one of the hardest problems I had with writing this was making it look good because I didn't want to use any outside libraries that I would have to download from the internet. So all of this is written by me. So the way I figured out how to print good characters to the screen with color and make it look good was to use different classes and escape functions or escape ANSI escape codes. So these are what ANSI escape codes look like. It's basically an invisible string that prints out to the console and it changes the color. So this one will make it bold black on a white background. This one will make it bright red on a white background, and this will do blue and then green, and then this one is just the white constant. So what I use for holding what characters should be printed what color is a structure that has the hold character and the escape code. And here I have a bunch of constants that I will be using. Basically, they're just different uh, different things that wouldn't normally print to the console characters. Things like the double line or the cross here. And these are also the filling on the back of the cards and the edges. I wanted to make it look very smooth, and I couldn't do that with the normal things that would print out to the console. So I had to use Unicode characters. That's what they're called. So all of these correspond to a specific character, which should be need don't need to explain that. So I guess how to the creating the card. So whenever we create the card, we set the color and the color sequence. So color is I won't go into that depth, but color sequence is the main thing that will be holding the colors, the escape sequence of the color that we will need to use when printing the characters. And we also decide how to display the card depending on how it's flipped. So if it's flipped on its back, which is this chunk, it will replace a certain section of it, which, if I can pull up this, is these S's here. These are the S's and the N's, if it's flipped over, are replaced with uh, fill images or a fill character. And if it's flipped face up, I replace the first two with the value, which this is giant switch is used for that. So there's cases for I don't think you need to know that. But if the card's value is 1, it gets an A, otherwise it gets its normal value. And then 11 is Jack, 12 is Queen, 13 is King. And if it's flipped face up, the S's on this side, or on this diagram, I guess, will change into whatever the suit. It depends on the suit. So, say we had an Ace of Hearts, it would be a card with a value of 1, so it would print an A here, and then it would say that the H would go here, and then it would replace this little block of S's using a for loop. And its color would be set to red because it's H. The suit is H. So, other than the card, there is the stacks, I guess. No, those are so the stacks are basically just vectors. I used the field stack because it was easier for me to visualize in my head while coding, basically. Or I used the class. And I use this in conjunction with the playspace class. So this class I use pretty heavily. I think it's the second largest class behind card, but card is pretty empty. Yeah, it's mostly just repeat stuff. So the main stuff here is displaying the space, which is do whatever your refresh is, and then print out each character within the 2D array, which we print out white escape code first, followed by the image, the character's escape code, followed by the hold character. So, actually, wait. Where is it? Oh, right. It's elsewhere. So, I guess I would have to start in playspace place card. So, and this is the main thing I use to get cards where they need to go. Of that, I use that structure I showed earlier, and I make a temporary character, and I set its color escape code to whatever I have at the time, or whatever card is being placed. And I then get each character within the image of the card, and I replace the image of the play space at a certain X and Y coordinate with whatever is there. And I use a for loop to replace just the size of the card. And so that means the play space is a 2D array of color care, which is the structure that holds the hold character and color escape code. And it basically uses this to print just the color, like the pure color of the character, and then the character. And so this took me like the most time out of anything, I think, to figure out. And so that's why I want to show it. Other than getting things to display correctly. Oh yeah, and then there's place stacks, which places all of the stacks within the space, and then there's full refresh space, which is just refreshing the space every time. And so the next thing I'll show is how I interpreted controls. And so within the actual game function, I have a getLine function, which is getLine player control. And so that gets whatever the player enters in, and I have a controller handler function. And I basically have a giant if-else blocks to translate whatever the player entered into what it should be within the code. So if the player enters a value of A for ace, the moving card value will be set to 1 and so on. And then this is the set for translating the from stack and then the to stack. And then I have a different function to handle the moving of the cards. That's up here. And so basically this is the most logic intensive area of the code. The basics of Solitaire is that you can only move a card if the card you're moving it onto is of a different color and a higher order. So I basically have a bunch of complicated if statements. They're not too complicated, but they're for moving between different stacks. Like you can move cards from the Talon to the Tableau, but you can't move cards from the Tableau to the Talon, and drawing is a different thing entirely. So this is basically just the function where all that gets translated, so it's not an incomprehensible mess. You can decode it just a bit. Oh, this is the draw card function. It's pretty simple. It just changes whatever is at the top of the Talon. Whatever is in the Talon stacks vector. Remember that the stacks are all different, are all of one class, which is a field stack class. So I use the vectors to basically keep track of whatever cards are in there. And so this chunk basically draws the card normally, and this bit recycles. Oh yeah, and every time a move is done, we get a different structure, which is of move composition, and I define that here. And for each move, I have to store the card value, the from index, the to index, the dual flip, and move type. So there are several different move types in the game. There's like drawing, there's moving cards to the foundation, in between the tableau. If it's just the bottom card within a stack of the tableau, it's a lot easier to do than moving the entire whatever's underneath that card. So down here we set the move type to you initially, so that if the move never finishes, the move type gets stored as you, and whenever I try to undo a card, it won't do anything if it's you. So basically, while it's deciding if the move is legal, it's constructing whatever this move is. So at the end, it adds whatever this move is into the full move list. And force undo. See if the move type is U, then it will just go to the end of function and it will just remove it. I decided that it would still count as a move. You can see where I count all the moves here, if I'm correct. Number of moves, yeah. So these are all the locations where I count a move. So if there's an error with whatever you entered, then it didn't recognize the function or whatever you entered, and it will just throw out an error. There's no penalty for that. Uh, but if you decide to draw a card, that's a number of move. That's a move. If there are no moves, it won't do anything. It'll basically say no moves. If the move list size is not 0 and move status is U, oh yeah. If the last move you did was unknown, it will still count that as a move, and it will add another move onto that if you decide to undo that. So you really have to be careful and think about your moves beforehand in order to get a low score or a low move count, which is basically the score. Yeah, that's. Other than that, I think that should be it. There shouldn't be anything else that I am dying to explain. Oh, yeah, I should probably explain. Now I'm off script. Just expand all of this. So this is the initial game setup. So rather than making the cards, the stacks, and the placing the stacks all by hand, I use different functions or different loops to create all of them at once. And then after that, I only refer to the cards by their index values. And I use their class functions or class methods to get their values and see if I can move a card onto them and whatnot. And for the stacks in particular, I make all of the stacks. This is it. So I make all of the stacks using all stack types, an array called all stack types, which is defined way up here. So I have these stack types, which are all the stacks, and these I have a stack index enumeration, which allows me to freely reference whichever pile within the stack, or the not stack, but the vector of stacks. That's uh, but yeah, that just allows me to reference it more easily further into the code, which is up here actually, because I make my my move composition, my deck, and my stack, my all stacks via a vector, my stack of stacks. I make that all global so that I don't need to like have some weird way of communicating between the classes and whatnot. Oh yeah, and if I hadn't said it already, I didn't want to include anything that wasn't like already in here. The only two things that I use are stdlib.h and stdio.h, which are both standard C language libraries. So I didn't think of it as using someone else's code. I think I'm using only standard libraries to do all of this, which is, I think, the hardest part about this. If I'm not quite sure of what other libraries exist on the internet, but I'm pretty sure there are ways to do everything I do here in way less lines and way easier ways. But I decided to make this my way, so I have about 1,000 lines of code and all of it just to print an ASCII chart, basically. But it's in color and I think it looks good. So that's about that. Some things I wish I could do better. Again, the auto function. Displaying the cards was one of the things. If I could do better, I would. I originally wanted to use images and see if I could print them to the screen, but I asked developers that I worked with and not worked with like on this project, but I work with like at my job. I asked them about their knowledge of C++ and how that would be possible, and they just told me to use outside libraries, so I just gave up on that. And so that was the end of that. So if as long as I'm using the ASCII art, I have to refresh the console in some way. And if the auto function had to be animated in any way, I would have to make a faster way to refresh the console. And the way I refresh the console right now is about as fast as I could get it. That's down here. Yeah. While printing the correct color and the correct characters, I have to see out the escape sequence of white C first, because if I do the black escape sequence, it will appear as a lighter black instead of the bold black that you normally see. I can just pull that up pretty easily. Yeah, and so this black here and the black at the bottom of the screen, these would appear light gray if I wasn't printing out the white color each time. But other than that, that's about it. Thank you. That's not the quit button.